Section 2.7 is solving proportions. I can solve and apply proportions. Big ideas. A proportion is an equation that states that two ratios are equal. If two ratios are equal and a quantity in one of the ratios is unknown, the unknown quantity can be found by writing and solving a proportion. A proportional relationship can produce an infinite number of equivalent ratios. Any two of these can be used to write a proportion. So for example, 1/2 is a ratio. That's the same as 4/8, which is the same as 12/24, which is the same as 53/106, which is the same as 2 billion/4 billion. Okay, we can come up with an infinite number of equivalent ratios. We can multiply 1 by anything we want to and 2 by that same value, and it's an equivalent ratio. And we can use any two of those to write a proportion because they all mean the same thing. If we were to simplify them down, every single one of them would simplify down to 1/2 or a half. So in example 1 here, we have a proportion. We have two fractions or two ratios set equal to each other. So if I look here, what's happening to my variable? Well, right now it's being divided, and we get rid of division by multiplying. So I'm going to multiply both sides by 12, but remember 12 as a fraction is 12/1. So 12 divided by 12, we extend that, cancel each other out, and all I have left on the right side is an m. On the left side here, I get 84. 12 times 7 is 84, and 1 times 8 is 8. That reduces down to 10.5, or 21/2. Okay, so we figured out what's happening to our variable and solved. Same idea here. Feel free to pause and give it a try if you'd like. What's happening to my x right now? Well, it's being divided. We get rid of division by multiplying. And whatever I do to one side, I do to both. Remember, we can write whole numbers as over 1 to turn them into fractions. So 7 divided by 7 cancel each other out. All I have left is x. On my right side, 7 times 4 is 28. And 5 times 1 is 5. That doesn't simplify any further, so you could leave it like that, or we could take it to 5.6. Either way. In the proportion a/b equals c/d, the products a times d and b times c are called cross products. And we can use the following property of cross products to solve a proportion. And if you look at the take note on page 125, it's the cross product of proportions. And what it tells us is that we can take a times d, our cross product, and b times c, our second cross product, and set them equal to each other. Okay, cross products of a proportion have to be equal in order for it to be a proportion. So that lets us solve proportions when our variable's in the denominator, because here we can't just figure out, okay, what's happening to our variable. It's not as easy. We have to get rid of our fractions. And in order to do that, we can use cross products. So what this is telling us is that I can take my two cross products, 4 times x and 3 times 8, and set them equal to each other. And this works anytime we have two fractions set equal to each other. It's like we multiply by x to get rid of our division, and then we multiply by 3 to get rid of our division. So I have 4 times x and 8 times 3. Cross products. So we can simplify our left side, simplify our right side, and solve for x. Right now x is being multiplied by 4. We can divide both sides by 4. And we get x equals 6. If we plug it back in here, 4/3 equals 8/6. Well, if I reduce 8/6 by taking a 2 out of each of them, I get 4/3, which is equivalent. Now, feel free to pause here and give this a try if you'd like. Again, here I can either solve by taking and multiplying by 3 to get rid of my division, or I can use cross products. And I'm going to use cross products just to get some more practice on that. So I can take y times 5, set it equal to 3 times 3. Cross products of a proportion have got to be equal to each other, otherwise it's not a proportion. So if I simplify my left side and simplify my right side and then divide to get my variable by itself, I get 9/5, or 1.8. And if we plug it back in here, it will work. In example B here, or 3 here, we're going to do the same thing with our variables. In order to solve, I have b's on both sides, so I need to simplify as best I can, and I can do that using cross products. I can still take 4 times b minus 8, but keep in mind this b minus 8 is one thing, so it goes in parentheses. Okay, remember fraction bars are like grouping symbols. It's like there's already parentheses here for both of these. Fraction bars are like grouping symbols. Same thing on the other cross product. I can take 5 times b plus 3. But remember, we're taking 5 times that entire b plus 3, so it goes in parentheses. And I set those cross products equal to each other. Now, before we can solve, I check, is my left side as simple as I can get it? No, it's not. We distribute. So 4 times b and 4 times negative 8 gives me negative 32. Now it's as simple as we can get it. Is my right side as simple as we can get it? It's not, so we distribute. I take 5 times b, and I take 5 times 3. And now it's as simple as we can get it. So once both sides are as simple as we can get them, we try and get all of our variables together on one side. I have 4 b's on the left and 5 on the right. I'm going to move them all to where I have the most b's, which is this side. So if I have 4 b's and I want to take them away, so I have no b's, again, the goal is to get no variables over here and all of them on this side. So if I have 4, I can take away 4 to get to 0. And whatever I do to one side, I do to the other. So 4b minus 4b gives me 0. Now I have b all together by itself. I can subtract so that it's the only thing on that side of my equal sign. B plus 0 is how I get b alone and isolated. So negative 47 is what b equals here. If we plug it into both of our b values, we'll get the same thing on both sides. Feel free to pause here and give this a try if you'd like. Again, we have a proportion here, which is 2 fractions set equal to each other. So in order to solve it, we're going to use cross products. I'm going to take numerator of one times denominator of the other and set it equal to denominator of my first times numerator of my other. Keep in mind, however, that this fraction bar is a grouping symbol. So it's like this 2n plus 4 was in parentheses. We take 5 times that entire thing. We distribute to simplify both sides. Left is already simplified, but on the right, 5 times 2n gives me 10n, and 5 times 4 gives me a positive 20. Now here, it's a little bit different than the last one because I only have variables on this side. So I'm going to move all my variables to that side. We could move our 6 to our 10 because 6 is smaller. We usually move our smaller variable. But I'm going to get all my variables together on one side and my number parts together on the other. And my numbers are already together, my constants, with that 20. So if I subtract 10n, 10 minus 10 is 0. Perfect. I have no n's left on that side. I have negative 4n's equal to 20. I already have all my number parts on one side and all my variables on the other. So all my variables on the left, my constants on the right. So to get n by itself, right now it's being multiplied. We solve by dividing, and we get n equals negative 5. And you could have still gotten a negative 5 had you kept, or had you moved the 6n. You would have just had it equal to 0, then subtracted the 20, and then divided. So just an extra step or two, which not the end of the world, but here we avoided that. When we model a real-world situation with a proportion, we have to write the proportions carefully. Remember, we're comparing two rates or ratios. So if our units are different, we have to have the same units in the same part of our fractions. So the proportion has to be written so that the numerators have the same units and the denominators have the same units. So if we look here, a portable media player has 2 gigabytes of storage and can hold about 500 songs. So we're comparing gigabytes of storage to number of songs. Okay, that's going to be our ratio, our relationship, gigabytes to songs. And we have 2 media players. Okay, our first media player has 2 gigabytes and 500 songs. we want to know for our second similar but larger media player, so similar means they're in a proportion, has 80 gigabytes of storage. And we want to know about how many songs. So again, it's really important here that our labels are the same in our numerator, so gigabytes and gigabytes, compared to, in our denominator, the same, songs and songs. That's very, very important when you set these up. So please be careful on that. Make sure we're comparing the same things. We have gigabytes compared to songs, gigabytes compared to songs, gigabytes compared to songs. And now we can solve using our cross products. So 2 times x is equal to 500 times 80. Simplify both sides. X is being multiplied by 2, so we divide. And our second media player can fit about 20,000 songs as our label. And if we plug that in there, 2 over 500 is the same as 800 over, or 80 over 20,000 if we reduce them down. So they do work there. Again, keep in mind, our labels have to be the same. Whatever we do on the top has to be in the top for both. Whatever we do in the bottom has to be in the bottom for both. Now, an 8-ounce can of orange juice contains about 97 milligrams of vitamin C. About how many milligrams of vitamin C are in a 12-ounce can of orange juice? Well, here I'm going to compare my ounces to milligrams of vitamin C. Those are the two things. We have one can that has 97 milligrams and another can that we don't know how many milligrams. So an 8-ounce can is going to give me 97 milligrams of vitamin C. Equal to, because we're talking about the same thing, we're still talking about orange juice, 12-ounce can over we don't know how many milligrams. We can use cross products to solve here. Again, make sure our labels are the same. So since I have ounces on top, I have ounces on top and ounces on top. Since I have milligrams on the bottom, I have milligrams on the bottom and milligrams on the bottom. Using our cross products, it's 8 times x equal to 12 times 97. Here you get 1,164. X is being multiplied, so we divide to get it by itself, which gives me 145.5 milligrams of vitamin C. So again, ounces over milligrams equals ounces over milligrams. It has to be set up the same. Quick recap here. A proportion is an equation that states that two ratios are equal. If two ratios are equal and a quantity in one of the ratios is unknown, the unknown quantity can be found by writing and solving a proportion. And that's all I have for section 2.7.